Okay, so today we are talking about straight lines. More specifically, we want to talk about the equation of a line. We're going to talk about parallel and perpendicular lines. Both are GCSE topics. We're just going to see roughly what they look like in the IB context, following a revision of the GCSE content. So in this lesson, we're going to revise this, which is a GCSE topic. We're going to see a couple of examples just to refresh our memories on this topic, and then we're going to move on to the relevant IB topic. So here I'm going to say a couple of things when it comes to problems with the equation of a straight line. Firstly, you need to remember that the equation of a line is y is equal to mx plus c, where m is the gradient and c is the y-intercept. So that is where the line crosses the y-axis. So I'm going to make a note here. C is called the y-intercept. And then the other thing is, we need to remember that the gradient of a line given 2 points, when you have 2 points which are x1, y1, and the second point is x2, y2, then the gradient is actually given by y2 minus y1 divided by x2 minus x1. So often this is called the difference. You might see it this way, dy over dx, or difference in y over difference in x. Okay, so let's have a look at this example then. They're saying basically we have a line which passes through 2 points. This is point A, this is point B, and we want to find the equation of the line. So the equation of the line, we know it's going to be mx plus c. We just have to establish what the m is and what the c is. Well, first things first, we know that the line goes through these 2 points, so we can actually use the 2 points to find the gradient. The gradient of the line is going to be the same thing as the gradient of the line segment which goes through A and B. So we will have to do y2 minus y1 divided by x2 minus x1, where x1 and y1 are the coordinates of the first point, and x2 and y2 will be the coordinates of the second point. So let's go ahead and replace those. Well, that's going to be minus 1, minus 1. What am I using? I'm using minus 1 as my y2, and I'm using 1 as my y1. And then underneath, we'll have x2 minus x1, which is 5 minus 1. So that's 5 minus 1 in the denominator. Let's see what that gives us. That gives us minus 2 over 4, which simplifies to minus a half, or minus 0.5 if you like. We tend to use decimals a bit more than fractions, but both are acceptable. So now, what do we know? We can actually rewrite the formula, the equation of the line, as y is equal to minus 0.5x plus c. So we are one step closer to the final answer. What we need to find now is this value of c. So to get this value of c, we can choose either to use a or to use b as a point. Both would give us the right answer. So you can choose to replace the coordinates of a or the coordinates of b in this equation. Now, I would personally choose a because I think the numbers are easier. But if you are somebody who likes a challenge and they like to make things difficult for themselves, you can choose the other. Or maybe for some reason you might think this is easier, the second one. Okay, so here let's go ahead and replace x with 1, y with 1 as well. So let's see what that gives us. So if we do that, we get 1 is equal to minus 0.5 times 1 plus c, which gives us, well, 1 is equal to minus 0.5 plus c. And then if we move the minus 0.5 to the other side, you get 1.5 is c, or c is equal to 1.5. So that is amazing news because we are ready to give the final answer. Y is going to be equal to minus 0.5x plus 1.5. So that would be the final answer as to what the equation of the line is. This is it. This is one type of problem we need to be familiar with. The second one will be problems to do with parallel and perpendicular lines. So let me just write a little bit of the theory here which we need to be familiar with. One is if you have L1 being y is equal to m1x plus c1. So basically just a line, but I'm just using the suffixes, sorry, c1 that should be. I'm using the suffixes 1 here because I'm going to have 2 lines. And the second one will be y is equal to m2x plus c2, just to distinguish between the two of them. So what do we need to remember? So we've got 2 things only. One is that L1 and L2 will be parallel when the gradients are equal. So that is when m1 is equal to m2. So this is one thing that we need to remember. The other one is that when they are perpendicular, they have a special connection between the gradients. It's slightly different. You can think of it in one of two ways. Either you think of it as m1 times m2 is equal to -1. So the product between the gradients is -1. If you rearrange that, you get m2 is equal to -1 over m1. And that one, you will often hear students or teachers saying, oh, the gradient is the negative reciprocal. So if you ever hear that strange terminology, this is called negative reciprocal. The reciprocal being one over the other thing, like an inverted fraction, flipped if you like. So that is what people will call the negative reciprocal. So in any case, this is the second bit we need to remember, which is when are two lines perpendicular. So in this particular case, we've got this line, which is y is equal to 3x plus 2. We've got another one which is parallel to this and passes through this point. So they've given us two bits of information. They've given us this bit of information. I'm going to call it 1. And then passes through this point. I'm going to call the second bit of information. So let's see. They've given us that y is equal to 3x plus 2. We have another line. Let's call it L2, which has equation y is equal to mx plus c. But we don't really know this yet. But what do we know? Well, we know that this line is parallel to the original. So the original is L. So we know that L2 and L are parallel. So using our theory, that means that the gradient is going to be equal to 3 because that gradient is equal to 3. So the other one must have the same gradient since they're parallel. So actually now we know we're a step closer now. We know that the equation is 3x plus c. That's the equation of the line we're looking for. Now, let's use that second bit of information. We know that it passes through 5, -1. So let's use that point, 5, -1, with our equation to find c. So this is going to be our x, and this is going to be our y coordinate. So let's see what happens when x is 5 and y is equal to -1. Well, we get -1 is equal to 3 times 5 plus c, which gives us -1 is equal to 15 plus c. So what is c going to be equal to? Well, if you subtract, if you do -15 on both sides, you get c is equal to -16. So now we are finally ready to say the equation of the line, which is y is equal to 3x minus 16. And that is the final answer. So you see, just to recap here, guys, we just break it down into the different bits of information we've got. When they say parallel, immediately you should go ding, ding, ding. That means same gradient. So let's use that. If they say perpendicular, you should again go ding, 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 and use this bit of information here from our theory. Right, and then finally, just to show you quickly an example where they say perpendicular, just to make sure I've shown you all different types of problems. Well, firstly, they say we've got an equation of a line which is y is equal to 2x minus 5. And then they say we've got another line, let's call it j, which is y is equal to mx plus c. We don't really know this equation, but what do we know? We know firstly it is perpendicular to line k, so let's call that the first bit of information. And then it passes through this point, which is going to be our second bit of information. Well, firstly, let's see. If these two are perpendicular, then we know something about the gradients. We know that the gradients have a product which is equal to -1. So m1 times m2 is equal to -1, or you can think of it as m2 is equal to -1 over m1. You choose which one you want to use. So the idea is that I'm going to use the product because I just tend to use this all the time, really. So 2 times the gradient of the second one is equal to -1. So 2m is -1, which means m is -1 over 2, or m is minus 0.5. So basically, we found the gradient is minus 0.5. So now we know this is the equation. Finally, second bit of information, let's go ahead and put that point, the -4, 8, because they said this line goes through this point, so this point must satisfy the equation of the line. So when x is -4, y is 8, let's see what we get. 8 is equal to minus 0.5 times -4. Let me just make that clear, it looks a bit messy, plus c. So that gives us 8 is equal to +2 plus c, which means c is equal to 6. Hopefully that wasn't too fast and people were able to follow that. Basically, now we know the equation is going to be y is equal to minus 0.5x plus 6, and that is the equation of line J. So this was a quick recap of the different types of problems that you could get asked in a GCSE question, which is regarding the equation of a line. So let me stop the recording here, and I'm going to be on the call obviously to answer any questions anyone might have.